Hello to everyone. Welcome again to my channel. So I will be discussing about generating patterns. My name is Sixto Paga Jr. Then don't forget to subscribe my YouTube channel Sixto Paga Vlogs. So this is all about patterns. As you will see, we have the example 2, 4, 6, 8, 10, 12, 14. Then the pattern is adding by 2. So from the first term, you add by 2, so the result is 4. Add again by 2, the result is 6. And just continue the process. Question number 1. What is the next term in the geometric sequence for negative 12, 36? First thing to do is know what is the definition of geometric sequence. If it is a geometric sequence, we will consider here the common ratio. To find the common ratio, simply divide the second term to the first term. In this example, the second term is negative 12 and the first term is 4. So if we will get the ratio of that, the answer is negative 3. And then you can also use 36 divided by negative 12. So if there is a common ratio, so you can easily determine the next term. Here is the solution. We will use this formula. R equals A sub 2 divided by A sub 1 is equals to A sub 3 divided by A sub 2. By substitution, we have negative 12 divided by 4 equals 36 divided by negative 12. So what is the value of R? R, small letter r, is the symbol for common ratio. So R here is equals to negative 3. Did you understand? Let's proceed to the next question. So the answer here is negative 108. How did we get negative 108, by the way? So if you have the common ratio, negative 3, the last term is 36, multiply 36 times negative 3, so the answer is negative 108. Next, question number 2. Find the common difference in the arithmetic sequence. 3, 13 over 4, 7 over 2, 15 over 4, then ellipsis. Now, the question here, you are going to find the common difference. If it is common difference, we are referring to arithmetic sequence. How to find the common difference of arithmetic sequence? So simply subtract the second term to the first term, or third term to the second term. In this example, we will subtract 13 over 4 minus 3. So what is the result? So this is the formula that you are going to use. D is equals to A sub 2 minus A sub 1. 13 over 4 minus 3, the answer is equals to 1 over 4. Therefore, the common difference is equals to 1/4. Next question. Question number 3. What is the sum of all the odd integers between 8 and 26? To find the sum, we will use this formula. A sub n equals A sub 1 plus quantity n minus 1 times d. What is the meaning of this? A sub n is the, so A sub n is the last term, A sub 1 is the first term, N is the number of terms, and D is the common difference. By substitution, the last term is 25. A sub 1 is 9. Then times plus quantity n minus 1 times 2. So why we have 25? Because the first digit or the number before 26, which is odd, is 25. Then how about 9? After 8 is an even number, then 9 is the odd number. So that is why we use 9 as our a sub 1. Now let us know first what is the value of n. As I said, n is the number of terms. So we have now 25 minus 9 equals to n minus 2. We just only transpose positive 9 to the left side of the equal sign. Then simplifying this, we have now 16 equals to n minus 2. Then to find the value of n, we have now 18 equals to n. Why 18? Because we transpose negative 2, so it became now 16 plus 2, which is equals to 18. Then dividing both sides by 2, so n equals 9. Now, going back to the question, we are going to look for the sum. We are going to use this formula. S sub n equals n over 2 times quantity a sub 1 plus a sub n. This one, an supposed to be a sub n. That is a subscript, the n. Then by substitution, we have now s sub 9, because the value of n is 9, equals 9 over 2 times quantity 9 plus 25. A sub 1 is the first term, then an or a sub n is the last term. Then simplifying this, we have now s sub 9 equals 9 over 2 times 34. Then the sum now is 153. So don't forget to write the formula, because in order to find the sum of the given problem, so you are going to use this formula. S sub n equals n over 2 times quantity a sub 1 plus a sub n. And at the same time, you are going to use the formula a sub n equals a sub 1 plus quantity n minus 1 times d in order to find the number of terms, which is equals to 9. Next, question number 4. If 3 arithmetic means are inserted between 11 and 39, find the second arithmetic mean. So, all in all, we have five terms. Okay, we are going to insert, because given there is the first and the last term, so we are going to insert 3 arithmetic means. Then we are asked to find the second arithmetic mean. Now, the solution will be, or the formula, a sub n equals a sub 1 plus quantity n minus 1 times d. So we are going to use this formula. By substitution, we have 39 equals 11 plus 5 minus 1 times d. So in this case, we are going to look for or solve for the common difference. Then once we get the common difference, so we can easily find we can easily insert the arithmetic means by using addition. Next is 39 minus 11 equals 5d minus d. What we did, we just only distribute 5 times d equals 5d, then negative 1 times d equals negative d. Or some of you might write the answer as negative 1d, so we will consider it correct also. Now, 39 minus 11, so we have 28 equals 4d. Then divide it both sides by 4, the common difference now will be 7. After that, once you have 7 as your common difference, Going back to the question, we have 11 as the first term, blank, 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 and the last term will be 39. So we are going to insert 3 arithmetic means. How? Starting from 11, just add 7. So 11 plus 7, the answer now is 18. And then plus 7 again, we have 25, and plus 7 again, we have 32. Then if you are going to continue the process, 32 plus 7, so the result is equals to 39. So this is the way or process on how to answer question number 4. Did you understand? Okay, so let's continue. We have question number 5. What is the next term in the harmonic sequence? 1 over 11, 1 over 15, 1 over 19, 1 over 23, and then ellipsis. Now in this case, as you will see, the numerators are the same, 1. While the denominators, it follows a arithmetic sequence. So that's why we call this harmonic sequence. Now, so just studying the patterns, because our main lesson here is generating patterns. So just look for the patterns of the denominator, 11, 15, 19, 23. So simply adding by how many? Okay, all right, by 4. Now, what will be the formula? D equals A sub 2 minus A sub 1. So we are using this, the denominator. So 15 minus 11 is equals to 4. So the common difference is 4. We can also use 19 minus 15, or another one is 23 minus 19. So the answer is equals to 4, the same. So that is the common difference. Once you get the common difference, just copy the numerator, the same one, then over 23 plus 4. So the answer now will be 1 over 27. So that is the answer. So what happened to the numerator? Of course, just copy it. Okay, so you only get the patterns of the denominators. Question number 6. If 3 geometric means are inserted between 1 and 256, find the third geometric mean. So in this case, we are looking for the geometric means. So what is the formula that you are going to use here? A sub n equals A sub 1 times r raised to n minus 1. First, we are going to find the common ratio here, the value of r, of course. Okay, so by substitution, we have now 256 equals 1 times r raised to 5 minus 1. Because the first term is 1, then the last term is 256, then the number of terms is 5. Because we are going to insert how many? Insert 3 geometric means. So we have now 1 plus 2 is equals to 2 plus 3 is equals to 5, of course. Now simplifying, we have 256 equals r raised to 4. Then look at the exponent, 4. In order to remove the exponent, we are going to apply fourth root, both sides of the equation. So the result r equals 4. If you don't know the answer, you can use calculator, scientific calculator, in order to find the fourth root of 256, which is equals to 4. Okay, then once you have the value of r, all you have to do is you are going to use multiplication. So from the first term, multiply. So we have the first term 1, blank, 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 and 256. So starting from 1, you have now the value of r, which is the common ratio, use multiplication. Unlike in the arithmetic sequence or arithmetic mean, you are going to use addition. In this case, geometric, you are going to use multiplication. Now, 1 times 4, 4. 4 times 4, 16. 16 times 4, 64. So the answer now, what is the, find the third geometric mean. So the answer is 64. So that's the answer, okay? Any question? Okay, question number 7. So we have now, which term of arithmetic sequence 4, 1, negative 2, negative 5 is negative 29? Formula: a sub n equals a sub 1 plus quantity n minus 1 times d. So in this case, you are going to look for the value of n. So number of terms. Then by substitution, negative 29 equals 4 plus n minus 1 times negative 3. So the common difference is negative 3. So looking for the value of n, we have now negative 29 minus 4 equals negative 3n plus 3. Then simplifying it, we have negative 33 minus 3 equals negative 3n. Then negative 36 equals negative 3n. Then n equals 12. So once we have the value of n, so the answer now is the 12th term. Which term of the arithmetic sequence 4, 1, negative 2, negative 5 is negative 29? So the answer is 12th term. Last question. What is the 6th term of the geometric sequence 2 over 25, 2 over 5, 2, 10 ellipses? So what is the 6th term? We have now the given terms are 4, so we are looking for the 6 terms of the geometric sequence. Of course, you are going to find the common ratio. So use this formula. Then by substitution, we have a sub 6 equals 2 over 25 times 5 raised to 6 minus 1. Then a sub 6 equals 2 over 25 times 5 raised to 5. Then simplifying it, so a sub 6 equals 250. Okay, guys, did you understand? So that's all for today's meeting. I hope you understand this. So if you have questions, feel free to message me in the chat room. Just leave your message. Thank you. And have a wonderful day to everyone. Bye-bye.